We're not going to be taking a look at creating an accurate z-depth that matches the rest of the scene and the cloud layers. View does not create a z-depth of clouds, but it can be really useful to have a pass. I'm going to show you how to create that z-depth that renders very quickly, although you do have to render it separate from the scene. So it does require two renders, but the way we're going to set up the clouds, they'll render very quickly. So you can load in this scene if you want to follow along. It's called Terrain Setup, and that's available in the Content folder. And what I have is just the ground plane and then a couple of terrains. It's spaced at different distances. So right now we don't have a cloud layer, so I'm going to go in and add a cloud layer, but I do want to go to the atmosphere editor first, to clouds, and then load it in. And we could either do this with full cloud cover, which I think I'm going to do just to show as much depth as possible. So I'm going to use the planetary cloud base, which has a nice coverage throughout the scene. And here's just a small render, the color output. Take a look at the Z, we can see we've got the terrains, but obviously the sky is not included in that in the clouds. So now we're going to create our Z-depth for the clouds. And it really doesn't matter how many cloud layers you have, you just have to pretty much copy the function we're going to create into the other layers. So they can be mixing throughout. And we can also set it up so that if they're intersecting with the terrain, if we use the multipass cloud masks, we can separate that. So the first thing we want to do is create a separate scene for this that we can render with. We're going to be making a lot of changes to the scene, so what you want to do is save out something separate after you have all your animation and everything done, and then you can start working on the modifications from there. So I just saved this new version as Terrain Setup Z Clouds. Now we're going to go into the atmosphere editor. We can edit the layer, our planetary cloud base, and what we're going to do is go over to lighting and effects, and we're going to turn off internal shadows, cast shadows, GI ambient lighting, and turn on the force ambient light color. This is going to cause it to render really quickly by turning off the shadows and the GI ambient lighting, global illumination ambient lighting. So we're going to go back to the color and density tab, and we are going to drive the volumetric color with a function. So if you do have a function set up already for the volumetric color and the ambient lighting in your scene, you'll just need to disconnect them because it's not really going to matter for the z-depth. So what we're going to do is use a noise to match the scale of the z-depth and have it carry out throughout the scene. So we'll right-click, go to Noise, we're going to use a math pattern, and we're going to use the tooth rectangular, or actually, tooth triangular. And if we take a look at the output, this is going to give us a linear output, which is what we need to stretch across the scene. So we're going to connect, we're going to add an input position for the material position, and then we want to set the scale to be the size of the z-depth, which is going to be 100,000, which is basically 100 kilometers in scale. And then what we're going to use is a color map, and we're going to edit, and we're going to change the first color for -1 to white, and for 1 to 0, so we have black. We're going to connect that to our noise, and then connect our volumetric color to that. What we also need to do is drive the ambient color for the sky based on that, and also the sun ambient color. We can delete all these constants. Now we have it set up, but we still need to make some modifications to the atmosphere to render this out correctly without any of the color interference with the sky and the ambient color. And we also need to create an offset for the position that matches the camera's position. So let's go ahead and set that up now. What we're going to add in is a math node, vector operations, and we're going to use an offset. Now the offset's going to work in reverse. So we do need to create sort of an opposite of the camera position. We're going to add in external dependency under input, set it to the active camera, which is the main camera position. And then what we're going to do is extract, right click on the offset and connect parameter. We can connect this then to that position for the offset. And if we open this up, actually we need to make sure because that offset wasn't set correctly. Connect that link from the offset after we open it up to the external dependency, the input to the position, and the offset is going to end up going to this noise node. But it's still going to be off because we need an opposite of the main camera. So we're going to go, and the easiest way to do this is just go to math, multiply by a constant, and we're going to use a value of -1, which will reverse it instead of 1. Connect that to our offset, and now it's going to be linked up properly to the main camera position. So now we need to make a few changes to the sky, and what we're going to do is also set up a separate light for the clouds. So let's go ahead and do that really quick. The sunlight, we're going to just select it, and then we can copy and paste. So Control-C, Control-V, just to make sure that the orientation stays the same as the previous camera. And any keyframes or functions should also be carried over with this. Under the sunlight, we're going to double-click on it, and under the Influence tab, and under Objects Influenced by Light, we're going to say Only Objects Marked Below and Uncheck the Planetary Cloud Base, which might not actually have an effect. I just like to do it to really show that it's not going to be influenced because we're going to be changing the color to black for the initial sunlight. So that's going to pretty much remove all the lighting from the clouds. And then we're going to open up this copy of the light. And now we're going to select all objects except the ones marked below. And we can remove the cloud base. Click OK. You can also set it up to influence the clouds. And then we're going to go into the atmosphere editor. We're going to go to the light tab, and we're going to override the photometric settings. So if you're using a photometric atmosphere model, you will have to turn that on, and we're going to change the ambient light color to black. What we also want to do is go into the main camera, and we're going to need to turn off any sort of gamma correction, turn off the natural film response, turn off the auto exposure. And if it's showing up as black, we'll set the exposure to 4. We're just going to match it up. And then we're going to go back into the atmosphere editor, go to the sky, fog, and haze tab. We're going to remove any haze any glow, and also the aerial perspective, at least as low as we can get it. And there's a couple more settings in the atmosphere editor, so we'll go back into there, go to the light tab. We're going to set the light intensity to -2, and then set our light balance all the way to 100% for the ambient light as well. And it looks like we might not be getting the correct exposure. So I'm going to duplicate this camera. Right click up here in the camera manager, store the camera, move over to camera 1. Set the exposure to 4. And I think I did set up the lighting a little wrong. So I'm going to go back, double click on the sunlight, change this to all objects except ones marked below. Turn off the specular and diffuse for the main sunlight. And then in the duplicate, we'll just set all objects. And it looks like there's just a problem with the exposure being a little different. So we can set it to 8, or what we can do is go into the atmosphere editor, turn off, set it to standard spectral, and keep the current atmosphere and camera exposure. And actually, there's one thing I forgot to do. So I'm going to set that back to the photometric. And actually, what the problem is, and I forgot, is that the duplicate sunlight is not as bright as the actual sunlight. Any duplicate, as long as the sunlight is active, is not going to have the exposure value that the initial camera has. So what we need to do is use exposure metanode created in the photometric exposure metanode section. We're going to right click, go to color, metanodes, and set up our exposure. And then we're going to add in a constant color of white and connect our exposure to that. Set our exposure to +4. Connect our color output, and that should take care of everything. So we could also go back into this sunlight and all objects except the ones marked below. And if we want, then we can make the rest of the scene black and just have the Z depth. So I'm going to go ahead and save the scene, and then we can render it out. So now when we mix this with the Z depth from the color render, we'll have an accurate Z depth for the clouds. Now if you need some more photometric settings or beyond the just black and white color, which is really kind of more of an 8-bit value, even though having the sunlight with the extra exposure should add the detail or the light exposure you need for 32-bit lighting. And I also want to note too that if the output of this, because the color output, if you're using multipass or the save render to disk, is going to be a much higher exposure. So if we were to take a look, browse previous renders, and take a look here, what the output's going to look like is with an exposure of +4, which is going to be really high, which is how the color looks. The Z won't look like that. So if your exposure is too high on the Z depth pass when you render it out, you just need to decrease the exposure by 4 in whatever post software you're using. So I'll just set that back. But we're going to take a look at doubling the output for the cloud value. And like I said before, if you have multiple clouds, you just copy the function that's in the volumetric color and paste it in. You might need to reset the camera. And right now we're in a new camera, so we can set it to camera 1 position. But the cameras are in the same place, so it won't really matter. But what we're going to do now is use a vector-based color with this tooth output. So the first thing I want to do is go into a filter. We're going to set it to map. Go ahead and connect that. And we're not going to connect the color map because we're actually going to end up not using it. And I'm going to start out by reversing this, so having the lower value of -1 actually equal 2, and the upper value equals 0. And this will give us that backwards gradient that we have in the color map. And then what we're going to do is create a composer math node. So math, vector operations, composer 3, and that's going to create our vector. Actually, there is another map node I'm going to add and set up the reverse differently. So I'm going to set the lower value to 0 and the upper to 2, and then create another map to take care of the RGB value that we're going to need. So we're going to connect that, and our output is 0 to 2, so we're going to do 0, and then I'm going to leave it at 1. Actually, I will go ahead and do 2 to give the full range, and instead of just doing, because what I was going to do is just take half of the value and set this to 255, which would be white. Because of the way we have to reverse the map node in order to, or reverse the noise in order to get it to match the Z depth properly, where black is the closest and white is farthest away, I'm going to just use the full range of RGB and just set that up as the initial value. So what we need for that is 0 to 255. So it's actually 256 values, but we're including 0, so we've got 255. So plus 256. So that's going to give us an output of 512 or 511. So we're going to do the lower value as 511, or upper value at 0. What I also want to do is just make sure that we don't have anything going below 0, because that's going to create some weird stuff for the scene. So I'm going to go ahead and add a filter and set it to floor at 0, just to make sure we're clipping that out. And now what we can do is take our composer, connect the X, Y, and Z, and now we need a color output. So we're going to go to Math, Vector Operations, or actually we're going to go to Conversions, and we're going to select Vector to RGB. And then what we can do is connect the color outputs to that. What we also need to do, as you can see, everything's white now. We need to double the output and the scale. So what we can do is just change the wavelength to 2. And actually, I'll try wavelength 1 and just set this to 200,000. And actually, there's one thing I forgot. And I forgot that the vector value for 255, 0 to 255, is actually 0 to 1 in a vector, and not the actual RGB value. So we can go back to the map and just set our lower value to 2. And that'll give us the extra range along with what we had before. So now when we take a look at the 32-bit version, we'll have twice as much distance. And you can basically continue that further if you need to. But in this case, 200 kilometers should be more than enough. Now I've just got this set up in Photoshop. And for the base layer, I've got the Z clouds that we rendered, the custom Z clouds. And on top of that, I've got the Z depth from the color render and being masked out with the mask that's included from the render output from the color as the top layer. And then what I'm going to do is add in, I'm just going to show you with different exposures how it matches up. And then we've got all that nice extra Z depth. And I'm just modifying the gamma right now so we can see all that really distant stuff. So then this will be incredibly useful when working with post, or working in post. And I also want to note, if you need something a little easier to be able to copy back and forth between different cloud layers, you can just create a meta node. I also want to show you what it looks like if I was to remove some of the cover from the clouds. And what we're going to see is a black sky. So you can even use that as cloud mask if you've got clouds that are above the terrains. And if they're below, intermingling with the terrain itself, and you need a cloud mask, and if you're above the cloud layer looking down over a terrain, then what you can do is go to the camera properties, and you're going to need to set up a multipass and make sure that cloud mask is turned on when you render that out.